All right. Looking at the first one, U, Q, R. So U, Q, R. These two lines right here should tell you which one that is. So your angle, you have your angle here. Is that bigger or smaller than 90? Bigger, so it'd be obtuse. And then do we have any sides that are the same? Two sides, three sides, or no sides? Two sides, so it'd be isosceles. Okay. Now we look at the next one. RST. RST. Okay. If you look at that, this right here should tell you everything you need to know. All the angles are going to be the same, and all the sides will be the same. So it'll be equal angular. And equilateral.
What is this?
Equiangular and equilateral. Okay. SRQ. SRQ. Take a look at that triangle. What type of triangle do we have? Good. It's the right because of the square in the corner. So this right here is your tell. Okay. Now based on that, you see that this is 16, right? This is 8. Is this side going to be the same length as one of those? No. So then it's going to be scalene. PRT. PRT.
This one be isosceles.
Good. So isosceles, and then what? Look at this angle down here. Is that going to be good? TQU. Good. Because this says this is 8. You know that this side is congruent to this side that's 8. And then this would also be 8. And if this is 60, because that's 120, this one would be 60 as well. So that's how you can tell that that one is the equals. And our last one, PQT. You were right. Yep, because look here, this one's right. And what type of angles are those? They're vertical angles. So they have the same angle measure. Then you have 16, 8, and this one's going to be not one of those. So then you're there, scaling. Okay, let's go down here to this. I'm going to do one with you, and then I'm going to have you guys do one on your own. And for those of you online, that'll be what you'll turn in. Those of you in class, just show me that before you're done. Okay. All right, so what this is asking is to find the lengths of the side. So what we're going to have to do is use the distance formula to find those. So the distance formula, I'm going to write it up here. Okay. So now if we come down here to this one, we need to find the length of JK, JL, and KL. Okay. So if we look at JK, X2 would be -9 minus -7 squared plus Y2 would be 1 minus -7 squared. So when you do that math, you get -9 minus -7 would be 2. So you'll have square root of 2 squared plus 8 squared, which would give you the square root of 4 plus 64, which would give you the square root of 68. Okay. So we don't actually have to find the actual distance of that. So then here, your next one, J and L. So we're going to have -1 minus -7 squared plus the same thing. Be -1 plus 7. What? So here, you have -1 from here, because it's x's, and there, and then you have this one and this one from here. Correct. Yep. So you'd have square root of 6 squared plus 6 squared. Good. Okay. And then your last one, KL, you're going to get, I'll use these two colors. So K and L. So you're going to have -1 minus -9 plus -1 minus 1. Okay, so where we got those from, you have -1 and 9, -1 and 1. Okay, so when we do that math, we'll get to here. -1 minus -9 would be -1 plus 9, so you'll have 7 squared, plus -1 minus 1 would be -2 squared. It's going to go to 49 plus 4. Oh, sorry, this is 8, not 9. That changes this to 64. Okay, so now that we have those, so now we're looking here. We have side 1, side 2, side 3. Are any of those the same? Yeah. Okay, so what type of triangle would we have if we have two sides that are the same? Good. Okay, so that's all you have to do. Those of you that are online, pick either 22, 23, or 24. Try it on your own and upload a picture, and you'll be good.